we fully see these large language models evolving and becoming as capable as humans for certain types of tasks. But much like humans, you're going to do the training, you're going to give them all the information up front, but then you have to monitor on the other side and continuously guide and provide kind of the clarifications so that their behavior fits what you're expecting from a CX perspective or otherwise. And I think that loop, much like what we saw with NLU, is an indispensable part of the whole process, right? This continuous maintenance and overseeing of the LLMs. Welcome, everyone. Thanks. Pleasure to be here. So I'm Greg. I'm the co-founder and CEO at HumanFirst. So we're building tooling at the intersection of NLU, LLMs, prompts, and data. We've been working on HumanFirst to solve problems around NLU, and now we're extremely excited by how we're going to be able to apply this technology to large language models. So the initial problem we solved and set out to solve with HumanFirst was to bridge a gap that we saw in the overall ecosystem, specifically for conversational AI, around transforming unstructured data into very structured labeled data to train very accurate NLU. We saw most teams using very inefficient tooling like Excel or building very technical tools and processes with expensive data science teams. And we thought there must be a better way to productize this whole process of working with unstructured data and turning it into business and artificial intelligence value. And so we launched 2 years ago a new product category that we coined as NLU design that makes building custom NLU much faster, much easier. It's no-code tooling, so you can think of it a bit like Excel for NLU data, and it helps non-technical stakeholders as well as technical stakeholders really go in a bottom-up approach and take any kind of unstructured text or conversational data and build taxonomies that represent what's in their data, and then apply that to train NLU for use cases kind of across the board. So virtual agents, chatbots, IVRs, but also analytics and insights. So this year, we're launching our V2 of HumanFirst, which is a pretty serious effort in rethinking the core workflows, and of course, incorporating a lot of now what's possible with large language models. So our V2 provides all of the same workflows for optimizing NLU that we had in our V1, but makes those workflows a lot more flexible and a lot more open in terms of the ways that you can go about and achieving those results. And the outcome of that is much more performance in the results that you get as you create the NLU. But we're also incorporating prompts and the input and output data of LLMs as first-class UX citizens. And it's really that mix of NLU and LLMs that, from our experience now in solving this problem for the last 3 to 4 years, tells us just how well NLU and LLMs work together when you mix and match their capabilities across unstructured natural language data. So what I'm going to show today is one of the applications of this, the way that these technologies work together, and show how, in the case of voice and text data analytics, it's by combining NLU with LLMs that you can get to the types of insights that are otherwise very, very hard to get. And so the flow is simple, and you kind of mentioned the importance of summarization, and we agree it's a very, very big use case for LLMs. So if you think about taking a large amount of unstructured voice data, you can start by summarizing those voice transcripts. And then using NLU, which is very powerful and capable at scale, to explore all conversations that would match a certain type or part of that summarized data. And then take the output of that and then run that using LLM again against a query that would allow you to go and get more qualitative insights from this curated data that you've gotten with NLU. And the output of that LLM query, again, can then be queried and explored using NLU to automatically build more granular taxonomies, for example, around the reasons for a complaint. So what we're discovering is that while LLMs are extremely powerful, at scale, NLU and the underlying technologies like semantic search and embeddings really allow us to scale that process and to go and to do things that are otherwise very costly or more time consuming. So I'll just end that by showing kind of the workflow for how HumanFirst integrates within a stack to achieve what I just showed. So in the case of call centers, if you have call recordings, the first step is to transform that with speech to text into high quality call transcripts. And I think the timing today is absolutely critical. 6 months ago, we did not have open models like Whisper that out of the box give perfect transcripts. And so this is one of the reasons why I think that we haven't had this type of breakthrough yet. But now we do. Call transcripts are perfect quality, and you can run them through summarization endpoints, OpenAI, Cohere, other large language models to give very, very high quality call summaries. And that's when then a tool like ours allows you to explore and to work with that data in a really, really efficient way to extract structured data and insights. And that's what I'm going to show you now in the demo. What I'm going to show you is how I'm going to explore voice data in a HumanFirst workspace. So what you see here is an empty workspace. So I'll just start by loading data that we've already prepared. But so ABCD is a public data set of conversational data that is used by a lot of companies to kind of bench and stress test their models. So it's conversational data. And what you see here, I've just loaded it. And in HumanFirst, you'll see here the utterances of those conversations. And you see that you can look for any utterance in context, where it is and where it fits within the full conversation. So if you think about like wanting to extract understanding from this type of data set, as soon as you have a lot of information, it becomes extremely noisy. So we can start by doing something as simple as grouping these utterances by conversation, which will means that this will represent a full conversation. We can sort by then the ascending date. So this is going to give us first a look into what are the kind of first utterances that a customer gave in a conversation. For example, I would like to change my phone number on my account. So this is already a first step to tell us what is the initial intent of a conversation. But of course, there's a lot going on afterwards in the conversation that you're going to have to figure out. So as you're building an NLU model, or as you're trying to understand what's in this data, the core problem is really figuring out the labels, figuring out these intents, these taxonomies. So out of the box, HumanFirst helps you do that on this data using capabilities like clustering and semantic search. So I'll show you that, but then I'll quickly show you how it becomes limited with voice data that's very noisy. So turning clustering on, you see that what we're going to do is we're going to bring up things that are semantically similar and that represent recurring topics. So these are things that you might be interested in looking at through HumanFirst. For example, I'm looking to have my name embroidered on a jacket. So this is a cluster, and you see that these are utterances that represent that particular type of intent. So in HumanFirst, you can select this and you can create an intent immediately. For example, embroidery question. Oh, embroidery question. And I can assign that. And I see now that I have my utterances that are representative and can be used to train an intent that would recognize this type of question. And that also allow me to go from an intent and to look at the unlabeled data now that continues matching this intent. So I can see, sorry about that. I'm going to just come back. So in HumanFirst, I can, I can start from a given intent that I've created, for example, embroidery question, and I can look at the rest of the data that is asking me, or where users are asking about similar types of questions. Now, to take a step back, this is the process that our customers are using today to kind of identify and to build intents and to build a taxonomy here that represents. But it's very still time consuming when you look at the amount of noise that there is in voice data. So what we're doing with HumanFirst now is allowing you to use summarization instead to do that much faster. So I'll show you the flow of how this works and give you an example. So I'm going to group these by conversations again. And I'm going to bring to the stash a bunch of conversations. So since I've grouped by conversations, everything I'm adding here to the stash is an utterance from a conversation. And I'm now going to apply prompts to directly transform and act on that conversation data. So I'm going to create a summarization prompt. And I'm just going to go and paste it because I have it here. I'm going to create a prompt. I've selected input data. So this represents 6 full conversations. And now I'm going to run this prompt, summarize the following conversation against kind of in a for loop against this input data. So I've curated and limited it to a very small amount of data, because what I'm interested in doing now, first and foremost, is saying, do I have a good prompt to summarize? Am I going to get good summarization results out of this? So I'm going to run this. So this is running against OpenAI. And we're quickly going to see the results of the summarized output of these conversations. I'll just give it a second to run. All right. And so here you see this is the NLG tab, so the generated data. And you see we have 6 conversations effectively. We've transformed these raw conversations into their summarization equivalent. So immediately this converts and transforms the problem. Instead of having to classify and create a taxonomy from extremely noisy data, all of a sudden we have very, very simple summarization elements that are easy to explore and to start creating a taxonomy from. So of course, this prompt might have not led, we might identify things here that we want to change. We might want to improve the prompt. And so you can quickly change the prompt itself and rerun the same prompt against the data until you're kind of satisfied with the transformation that you've got. Once you have that, you can run that same prompt against all of your data, for example, to summarize everything. So that would take a bit more time, but we've prepared that ahead. So I'm just going to load that data to show you how then we can take the full conversation summaries and work with those. So I'm just going to load all of the summarized data, and I'm going to disable the raw data so that we're only left with the summaries. So I see it's going to take a tiny bit of time. Okay, so now we have effectively the same conversations, but every one of them is now summarized. So what's great is that the same clustering and semantic search capabilities apply, but now we can do that on a much cleaner type of data. So for example, I could say the agent was able to delay the shipment of the order to next week. So I can take this element. So I'm going to put in another stash. Actually, I'll go for another one. The customer is calling to return a shirt because it was the wrong size. So I'm going to select this, and now I'm going to find all of the conversations where this type of thing happened. So find things that are similar to stash. So customer returned a pair of jeans which were wrong size, item because of the wrong size. So I can curate now a bunch of conversations that match this. And I'm going to go assign these to an intent, for example, wrong size. And I'm going to label them. So now I have started to curate a set of conversations that represent this problem. Now, what's really interesting is that why don't we use an LLM now to query against this data and find more specific information? So I can do that. So I'll just start another stash, and I'm going to take all of these conversations as input to another prompt I'm going to use. So I'm going to stash these, and I'm going to go back to my prompts, and I'm going to create a new one. I'm going to say, for example, was successfully resolved. So this is a prompt that I'm going to create on the fly. I'm going to say, you are a call center manager reviewing conversations. Was the customer's query? And if not, why not? Single sentence. And then I'm going to use a magic little helper element here. So what this does is it's simply going to take the summary that I'm giving it, but it's going to go back to the source data and run this query against the actual raw conversation that this was summarized from. So now if I run this NLG from stash, I'm actually going to be running this query, was it successfully resolved, against this summarized data. So I'm going to do that, and we're going to see the output of this. And this is you can think of the types of queries that you can run here. You could say, did the agent ask this type of specific question that he's supposed to in this kind of scenario? What was the personally identifiable information for all of these customers that had this type of problem? So you see here, I have my output. And if I explore it, the customer's query was successfully resolved. And what's interesting is that if you run this against a lot of data, then you can start mapping together, again, using semantic search and clustering and say, okay, show me the types of ways that it was resolved, right? You can cluster and you can start an exploration and go and find semantically similar things in the output of the LLM. So this is the type of interaction that leads to very qualitative and then quantitative analysis of the data, and that we're really excited about. I'll stop there and we can go into the Q&A where I'm sure Bret's going to have more questions.
Yeah, Greg, that was great. I really appreciate you showing that. I love it when we get from ideas to actually showing something work with these technologies and something like really practical as well. Plus, I like this idea that you're not just generating a response. So if we think about this, I'm kind of thinking about your background here and what you were doing. There was this problem around observability, visibility, discoverability within natural language data. And so you first kind of solve that problem for the NLU space. And then we move into LLMs, and it actually seems like, in a lot of ways, maybe even a bigger problem.
Yeah, I think so, because with NLU, the main problem was understanding the input to the NLU. So all this unstructured data that, for example, user inputs, classifying that. The hard problem with NLU is not the labeling, it's understanding and building this taxonomy of long tail, right, inputs. But the output of NLU is classified data. It's a classification, right? It's this label or that label. With NLG and LLMs, you also have to understand the output of those models in order to obviously identify issues like hallucinations and types of behavior that shouldn't be acceptable. But also, if you want to improve the performance, if you want to supervise or control in a certain way what the LLM is doing, you have to start by observing and understanding how it's performing today.
Right, and really, just to put a finer point on that, for the NLU-based systems, the input is this completely unstructured data that you have to do something with, and your intent recognition solutions hopefully give you a good answer. But then as you're trying to look back at it, you've got all this just pile of data. And when we look at LLMs, it's both directions. And I think that it's really interesting to me. So first of all, I don't think a lot of people have solved the input model. I mean, I think you have a solution for that, but I'm thinking about the end users. There's not a lot of people who have done that. You talked about spreadsheets and data science teams and waiting 3 weeks to get an answer. And do you even know that's the right answer, just because it's based on what they looked at? But one of the things I talked about in my presentation up front was this idea of risks. And one of the really big things is transparency. This is starting to come to the fore. We see this with government regulators and things like that in this consumer space, but we know this is a big factor in the business space in saying, okay, I like the idea of the benefits this can deliver, but how do I know what's coming out of there? How do I know how to make the most of it? How do I use that data, input and output, to retune my models and make them better?
Yeah. And I think this is a lot. I mean, there's the kind of the pre-deployment. So before you even push anything out, you want to kind of validate how it's going to work on your historical data. You want to be able to stress test it and back test it. And I think that's the type of tooling that we've seen for NLU was missing. This is the gap in terms of this foundational data-centric tooling, which I think is just going to be even bigger with large language models, where the value is so high, you want to use it, but the risk is there. So as you said, it's both prior to deploying and then post deployment. I mean, we fully see these large language models evolving and becoming as capable as humans for certain types of tasks. But much like humans, you're going to do the training, you're going to give them all the information up front, but then you have to monitor on the other side and continuously guide and provide kind of the clarifications so that their behavior fits what you're expecting from a CX perspective or otherwise. And I think that loop, much like what we saw with NLU, is an indispensable part of the whole process, right? This continuous maintenance and overseeing of the LLMs.
Yeah, absolutely. I love this idea of being able to measure the output and like analyze it in some way that you can not only perform your job better, but you can also show the other people in your organization what you did and why you've made the changes you've made, how you're going to make the model better. And then the other thing, this idea of the concept with the call centers and just like the voice data and being able to get really good transcripts and then summarize them, a completely different idea. It's not about optimizing a single solution that interacts with your customer. It's about identifying new solutions that you could do something like what Jordan and I were talking about, robotic process automation. It's like, how many of these things that just show up in our customer call center interactions could we actually just turn into an automated system to resolve?
Yeah, and this is where we see a lot of the value today is really upstream, kind of before you even decide what you're doing, the ability to go and to make data-centric decisions, because you have the data, because you're able to explore it really, really efficiently, is going to drive, I think, better kind of roadmaps and prioritization in terms of like what is the actual thing that we should be doing today that's going to drive the most value. And this is why we're really excited about this call center analytics space, because we see ultimately still a biggest part of the volume of conversations between enterprise and customers being through voice and call centers. Like conversational AI is big, but nowhere near as big as call centers. But all that data has not been leveraged in really any capacity because of those core technical blockers that I mentioned at the beginning, which were speech to text and now summarization. Unblock that, and all of a sudden you have a massive trove of data that I think organizations are just, want to put their hands on, and it's the right time to do so.
It's not just like being able to access the data, but it's who can access the data. Whereas today, maybe you could have your data science team do this, but it seems like some of the tools that you're really focused on are about making this accessible to any type of analyst.
Yeah, and our vision and why we started HumanFirst is we saw this gap in productivity tooling. Effectively, we looked at landscape and we saw Excel as this fallback tool for any kind of tabular data, right? It doesn't matter if you're a scratch pad or you're really building a kind of model that's going to underpin your entire business, you turn to a single tool. And we saw natural language data and unstructured data as just as important going forward for organizations. You just need that single tool that anyone from like technical to non-technical users feels comfortable going in and asking questions. And I think with things like Microsoft and Google making this type of AI just so ubiquitous within their experience, people are very going to quickly get to this point where every single problem, you're going to turn to and say, let's just get an LLM to solve it, or let's just get a foundational model to attack this. And I think you're going to need this type of tooling like Excel, but built for this new generation of capabilities.